Alright, so here's another ellipse problem where our center is not at 0, 0. And as I previously mentioned, we are now given values for h and k, so it's easy to just pull them right off. So the center is always h, k. So, and again, if these are subtraction signs, then your h is going to be positive. If these are addition signs, then your h and k will be negative. So for this problem, our center, since that's negative, h is positive 2. Since that's negative, k is positive 1. So there's our center. And now we need to identify a and b. And again, a is always the larger of the two values here. So this one right here is a squared, since that's the larger, and that one's b squared. And since the larger value is associated with the x term, this is going to be an ellipse that looks more like this, as opposed to the last one that was an up and down ellipse. Okay, so now we need to identify what a and b are. So a squared equals 25, so of course a is plus or minus 5, since that's the square root of 25. B squared is equal to 4, so therefore b is plus or minus 2. Okay, so now we have all the basic information we need to graph our ellipse. We have, we have our center, and we have our a and our b. Okay, so when we go to graph these, it is very important to identify and remember which term the a and the b is associated with. So that's why I've written x and y over to the side here, because this plus or minus, the 25 was underneath the x term, the 4 from the previous screen was underneath the y term. So therefore, once we graph our center, so our center is at 2, 1, it's right here. So to determine where my endpoints for my ellipse are, I have to start at my center and then add and subtract, and one at a time, add and subtract the values for a for the x-axis. So I'm starting at 2 because that's the x value. If I add 5, then I'm going to have a point at 7. If I subtract 5, I'm going to have a point at negative 3. So that's the endpoints along, I'm sorry, the vertices, I guess is the technical term, the vertices for the major axis. And then to look at the minor axis, so again, this 1 is associated with the y terms, so to determine how far it moves up and down, we're going to do 1 plus 2, so I will have a point here, and then 1 minus 2, so I'm going to have a point right here. So therefore my ellipse is a very skinny oval. Like this. Okay? And again, to identify domain and range, domain is the possible x values, so that goes from negative 3 to positive 7. The range is the possible y values, because again, let me back up a little bit. Domain is negative 3 to positive 7 because that's the smallest possible x value. That's the largest. The range is going to go from negative 1 here up to positive 3. Ooh, brain fart. So negative 1, positive 3 is the range. And then lastly, we need to determine the foci, which we need this handy dandy little formula for again. So if I plug in the values for a squared and b squared, I would have c squared equals 25 minus 4, which of course is 21. So again, if you take the square root of 21 in your calculator, you don't have to do that. However, I will totally accept that c is plus or minus the square root of 21. You don't even necessarily need to graph it in your problem. But if you wanted to, the square root of 21 is equal to 4.58. So, and again, but that's from where your center is, and the foci is for the major axis, which is the long one. So you would add and subtract 4.58 from the x value here to determine the foci. So you'd have one at 6 point-ish, so about right here, and then a similar point down here. But again, you don't have to graph them. I'm perfectly satisfied with just including this on your homework. Please let me know if you have any questions.